Hello friends, good afternoon. So today we meet again with Lami's theorem, numericals. Yesterday we had derived Lami's theorem and then we had done simple problems based on Lami's theorem. Today we are taking a little bit complicated problem for Lami's theorem. You can see the problem is a string ABCD which is attached to fixed points A and D, has two equal weights of 1000 Newton attached to it at point B and C. The weights rest with the portion AB and CD inclined at angles as shown in the figure. So you can see that this is the diagram. This is a string A, B, C and D, right? A is inclined at an angle of 30 degree with vertical, B 120, C and D is inclined at 60 degree. Okay, the weights are 1000 and 1000 newtons. So what we have to find out? We have to find out the tension in the strings, right? So to find out the tension in the strings, what we have to do? We have to use the free body diagram. So to draw the free body diagram, first step is draw free body diagram. Okay. So what we will do, the whole string, that is A, B, C and D, we will split it into two parts. We'll take joint B and we will take joint C. And we will draw the two free body diagrams at joint B and at joint C. Suppose we draw the free body diagram at point B. Okay. So this is point B that we are taking. So this is point B. Okay. Now at point B we have got 1000 Newton weight in the vertical downward direction. So we can show 1000 Newton weight, right? Then we can see in the diagram that we have got string BC, right? So we can show this as string BC and we are assuming that it is subjected to tensile. So we are writing TBC, tension in the string BC. Okay, so this we are taking it as TBC. Now we can see that it is inclined at an angle of 120, right? So with vertical it is inclined at an angle of 120. So we can show that this inclination is 120 degree. Okay. Now second thing that we can see over here is that from point B we have got another string that is AB. So we can show the string AB, right? And again we are assuming that it has got tension. So tension in the string, that is T of AB, and it is inclined at an angle of 30 degree with vertical. Okay, so this is 30 degree with vertical. So this angle is 30 degree. Okay. Now if I want to find out this particular angle, if I want to find out this particular angle, okay, how can I find out? So this line, that is straight line, so it will form 180 degree angle. So we can get this angle as 180 minus 30, that is equal to 150 degree. So this angle is 150 degree. Okay. Now any other angle left for this? Yes, this angle is left. How to calculate this angle? So we know that the total angle is 360 degree. So if I want this particular angle, I can have 360 minus 120 minus 30 minus 150. Or in another way, if this is a straight line, so it is 180. So 180 minus 120, that is 60 degree. So this angle will be 60 degree. Okay. So now I will draw a diagram which is representing the forces and the angles. Okay, so now this is TAB. Okay, this is weight W, that is 1000 Newton, and this is force TBC. Okay, what are the angles between these three forces? This is 60 degree. Then this angle, that is 120 plus 30, that is 150 degree. And this angle, that will be again 150 degree. Okay, now I can apply my Lami's theorem. What does the Lami's theorem say? Lami's theorem says that each force, so what are the forces over here? So TAB, that is tension in string AB. Then TBC is equal to tension in string BC. Then W, that is equal to 1000 newtons. Okay, so now each force is proportional to sine of angle formed by other two forces. So what are other two forces? So this is TAB, other two forces are 1000, and TBC, what is the included angle? 60. So sine of 60. Okay, similarly TBC is proportional to, what are the other two forces? Then TBC. So TBC, other two forces are AB and 1000. What is the angle? 150. So sine of 150. Okay, and last is 1000, which is directly proportional to, what are the other two forces? So 1000 के अलावा दो फोर्सेस कौन से हैं? AB एंड BC. उन दोनों के बीच का एंगल कितना है? 150. सो साइन ऑफ 150. So we can get that TAB, we can get TAB upon sine 60 is equal to TBC upon sine 150 is equal to 1000 upon sine 150. Okay, this is our Lami's theorem. Now I want to find out AB tension and BC tension. So I will take TAB upon sine 60 is equal to 1000 upon sine 150. So what will be TAB? TAB will be equal to 1000 into sine 60 divided by sine 150. Okay, so we can get the answer of TAB as 1732 newtons. So first answer we have derived, that is TAB is equal to 1732 newtons. Okay, now we will take the another portion of the string. And what is the another portion of the string? So another portion of the string is point C. Okay, so now we will draw the free body diagram of this particular point. So first of all, I will take this as point C. Okay, so this is point C. It is subjected to again a weight of 1000 newtons, so 1000 newtons. Then we have the TBC. Okay, so TBC over here, right? So this is, we can show over here that this is T of BC, which we have already calculated. Then over here we have got tension in the string CD, so T of CD. Okay, now the important part is we have to find out the angle. So if you see over here, what is the angle over here with vertical? 60. Okay, so definitely over here with vertical it will be what angle? 60. So this angle we can show it as 60 degree. Right? Then similarly we know that this angle is 120, so definitely this angle will be also equal to how much? 120. So we can show over here that this angle is 120 degree. Okay, now what will be this angle? So we know that it is a straight line, so total it will be 180. So this will be 180 minus 120, that is equal to 60. Okay, and if I want to find out this angle, what it will be? 360 minus 120 minus 60 minus 60, or I can take this as 180. So 180 minus 60 is equal to 120 degree. Okay, so now if I want to draw a diagram, so what will be my diagram? That the diagram will be, this is point C. Okay, this is string CD having tension, and this is string BC. So we can show string TBC. Okay, now I want to draw the angles. So what is angle between BC and CD? 60 plus 60, that is 120. So we can show over here that this angle is 120. Okay, now I want to find out the angle between 1000 and string CD. That means this angle I want to find out. So we come over here. What is the angle between string CD and 1000? 120. So we put over here as 120 degree. Now I want to have the angle between BC and 1000. So we come to this diagram. BC and 1000, it is again 120. So this is 120 degree. So this whole diagram is called as a free body diagram. Okay, now I know the value of TBC, so I can easily calculate the value of TCD by applying the Lami's theorem. So what is Lami's theorem? TBC is proportional to sine of angle formed by other two forces. What are other two forces? CD and 1000. So 120. Then TCD is proportional to sine of angle formed by other two forces. So this is CD. What are the other two forces? BC and 1000. What is the angle? 120. And 1000, that is proportional to sine of angle formed by other two forces, that is 120. So in Lami's theorem we can write down TBC upon sine 120 is equal to TCD upon sine 120 is equal to 1000 upon sine 120. Okay, now I know the value of BC, right? I can put that value which I have calculated in the previous. Okay, or I can take these both to find out the value of CD. So suppose I take TCD upon sine 120 is equal to 1000 upon sine 120. So we get the answer as TCD is equal to 1000 newtons. Right? So we get our two forces in the string, that is BC and CD, as 1000 newtons. Okay. Similarly, I can find out the value of AB, which we have calculated in our previous problem, that is TAB, that is equal to 1732. Okay, then right, TAB we have calculated as 1732, then TCD we have calculated as 1000, and now I want to find out the value of TBC. So again for TBC I can find it out by applying the equation. What is the equation? TBC upon sine 120 is equal to 1000 upon sine 120. Okay, this equation I have taken TBC upon sine 120 is equal to 1000 upon sine 120. Alright, now sine 120 cancels, so TBC is also equal to 1000 newtons. Okay, so we are able to calculate the forces in the members AB, BC and CD. Okay, thank you.